Now let's continue to determine limits from the right to the left, and also the limit as x approaches 0 of f of x. Okay, so I'm just going to get started by drawing this piecewise function. For x that are smaller than 0, we have 2x plus 1. So that is a y-intercept of 1 and a slope of 2. It didn't hit the dots properly. That's too bad. And note, of course, that we're going to have an empty dot here, though. And why is that again? Because we're not including 0. So it doesn't quite hit that point, right? It just has, so it has an open dot there. Let me make that a little bit more clear by erasing this. There we go. Okay, and for values that are of x that are greater or equal to 0, we have the square root of x. What does that look like? It will look something like this. I'm guessing that everyone's quite familiar with these graphs, and if not, again, you can always check them out on our website. How to draw square root functions, quadratics, linear equations, whatever you want. Okay, and now we do have a closed dot right here because we are including the 0 for x. Okay, so now we can already determine the limits. Limit as x approaches 0 from the right, that's what the little plus means, of f of x. That's going to be equal to, well, we're approaching 0 from the right, and y equals 0 at that point. Right there. So x equals 0. Sorry, the limit as x approaches 0 from the right of f of x is 0. Now, what if we're approaching 0 from the left? That's what the little minus there means. So we're coming this way from the left. And as we approach 0, or x approaches 0 from the left, y is 1, not 0. It's 1, 2, 3. So it's 1. So the limit of f of x as x approaches 0 from the left is just 1. So what is the limit of f of x as x approaches 0? Well, in order for this to exist, these guys must be the same, but they're not. They're 0 and 1. Therefore, the limit of f of x as x approaches 0 does not exist. That's it.